Hi, this is the second of our preliminary or review sessions for AP Calculus. Let's talk a little bit about domain and range of a function. If you think of a function as f of x or y equals x, then the domain of that function would be every value that x can be. In this case, x can be any real number. It can be negative, it can be 0, and it can be positive. So we would write the domain of the function using something called interval notation is negative infinity comma to infinity. This is representing the x-axis, the number line. This parentheses is called an open interval. Later we'll talk about that. It means that these endpoints are not included if we use parentheses. Example, consider the function 1 over x minus 2. So ask yourself, is there any value that x can't be? Well, if x is 2, what happens? You're dividing by 0, and that's a no-no. So x cannot be 2 and is not in the domain of the function. The notation would be, using interval notation, negative infinity, comma 2, comma 2, comma infinity. All endpoints are not included, and this would be everything but 2. Okay? Basically, any x value that makes the function divide by 0 would not be in a domain of a function. Here's another example. F of x equals the square root of x minus 4. What do you know about square roots? What's a no-no? You cannot take the square root of a what? Negative number. So x has to be, whatever is under that square root sign, the radical sign, has to be 0 or greater. So therefore, in order for that to be true, x has to be greater than or equal to 4. Otherwise, if x is 3, you would be taking the square root of a negative number. The notation here would be 4 comma infinity. Notice the square bracket to the left of the 4. This means that 4 is included, okay? And because 4 minus 4 would be 0, and the square root of 0 is 0. The open bracket means, of course, infinity is not included. Can't reach infinity, so it can't be included, okay? Domain of function is all real numbers unless there's some value of x that causes division by 0, there's some value of x that creates the square root of a negative number, or sometimes they simply specify a certain domain, and that would be whatever the domain is in this particular problem. Okay? Range. Okay, this is kind of like the yang to somebody's yin. The range is the values that y or f of x can take on. There can only be one y value for every x value. This is called being one-to-one for a function. Examples. Well, our first example, y equals x, what values could f of x be? Could it be negative? Sure. Could it be 0? Well, if x is 0, it's 0. Could it be positive? Yeah. So we would say the range here is all real numbers, or in interval notation, negative infinity to infinity. Not so bad. Here's another one. F of x equals 1 over x minus 2. What can't you do? Divide by what? 0. Okay? So obviously, you're never going to get 0 for y here because 1 divided by any number will never be 0. Okay? Can you get a negative number? Well, yeah. If x is 1, do I get a negative number? What is the limit of the negative numbers, or how many negative numbers can we get? We'll see that in a minute. Okay? X, we said, y can't be 0. Could it be positive? Well, yeah. If x is 37.5, do I get a positive number? Yeah. Again, what positive numbers could it be? We're going to look at the graph for right now, and we're going to see that really the range of this function is negative infinity to 0, okay, and 0 to positive infinity. Okay? Let's take a look at the graph. Here it is. Okay, as you can see, well, this is sort of asymptotic to y equals 0. It never reached 0. All values are included. It decreases without bound, which means it approaches negative infinity for y. It also increases without bound, approaches positive infinity. Notice that this occurs when x is 2. We'll talk about more about that when we talk about limits. And it also is asymptotic here to y equals 0. Never touches the x-axis. Okay? One last one. F of x equals the square root of x minus 4. What do you know about what can be under the radical sign? Can I have a negative number? Okay, no. Okay, so I will never have a negative square root. Okay, so y can't be negative. Could it be 0? Well, yeah, if x is 4, it's 0, and the square root of 0 is 0. Could it be positive? Yeah. If x is 29, this becomes 25, and the square root of 25 is 5. Let's graph it and take a look at it. Notice, okay, in this graph, actually, I'm not sure why this doesn't come down to 0 when x is 4. It may be something to do with resolution. This was an online graphing calculator that I used, but notice that this just keeps going up and up and up, never becomes positive, and it would increase without bound, in other words, approach infinity, if the graph was large enough. So the range here would be 0 included, infinity not included. To summarize, you find range by considering what values y can be given a certain value of x. Also graph the function to verify your answers. Later on in calculus, we'll talk about some other ways that you can determine range by looking at limits and that sort of thing. Okay? Peace.